Right, let's look at question 4 of the Acids and Bases worksheet, and as you can see, it came from the Northern Province, paper 2, high grade, November 2000. So, the ionization processes for two different acids are shown below. So all we're showing is how two different acids become ionized, okay, how they dissolve in water. First question is define the term a weak acid. Well, that's a fairly straightforward one, and it's one you're going to get asked often. So it is a weak acid is an acid which ionizes only slightly in water. Alright, so the pointer is that there's only there's a low percentage of ionization. There's not a lot of ions which are given off, okay? So the first one they ask you here, now they're following on to that, they say which of the two acids is considered to be weak. This is one of those things that you really just need to know. You need to know the list of strong acids that we've given you, and obviously anything that doesn't fit on that list has to be weak, plus all the organic acids, carboxylic acids, are weak. Number 1, okay, is ethanoic acid, so CH3COOH. Now when they say explain your answer, you can't tell them because it's a carboxylic acid. What you have to tell me is it only ionizes slightly in maybe I should write the word slightly in water. So it follows on from the first question. Then they want you to write down the conjugate acid-base pairs for the equation. So here you really need to make sure that your examiner understands what you've written. So we're going to rewrite the equation. So we've got CH3 COOH becoming H2O, and they gave it to us with double arrows, so we're going to write them. Gives me H3O plus, now they wrote it out as C2H3O2, so write it as it's given. Then we go, well, CH3 must go to the C2. We've already decided that this is my acid, which makes this my conjugate base. You must call it a conjugate base. Now, that means water has to be the base. Remember, it's an amphiolite, so it can change, and makes this the conjugate acid. Alright. Then they ask you, write an equation to show the anion in equation 1 reacts with water. So it's how does it react with water? Now, the anion is the negative ion, so it's the C2H3. Alright, so the C2H3O2 is going to react with water, and it's actually going to form CH3COOH. It's going to go back to the acetic acid and form OH minus ions. Okay, and when they mark this, it's giving me the reaction with water, giving me the products at the end, and then making sure it's balanced. The nice thing about these is that most of them actually are balanced straight away, so there shouldn't be too many balancing issues here. Now we get to the fun questions. Now they say to us a 20 centimeter cube solution of oxalic acid, COOH2, is titrated against a 25 mole per decimeter solution of sodium hydroxide with a volume of 28, and then they give you the unbalanced reaction. They're really nice, and they give you the unbalanced equation. They now want you to balance the equation, and the thing with balancing these is you need to remember that for every H that's going to come off, there needs to be an OH and vice versa. So the oxalic acid's going to give away 2 hydrogens. That means I'm going to need 2 NaOHs, which then means I'm going to make 2 waters. So the balanced equation is COOH2 plus 2 NaOH gives me COO Na2 plus 2H2O, and if you go and look at it, that'll definitely already be balanced. Then they ask you to calculate the concentration of the oxalic acid. There's more than one way to do this, okay? The simplest is to use our equation Na over Mb equals Ca Va over Cb Vb. The reason being that I know the volume of the acid I use, I know the concentration of the base, and I know the volume of the base, and the mole ratio comes from the equation. So this mole ratio becomes 1 over 2. Concentration of the acid is what I'm looking for. They said we used 20 centimeters cubed. We have, and that's 0.25, and we have 28 centimeters cubed of that. Okay, we're going to solve for Ca, and we get 0.175. If you round it off to 0.18, that's fine. Okay, then they say the sodium salt, the COONA, okay, reacts with water. The key here is they say it reacts with water. A reaction with water is hydrolysis. That's a given. Then they say, will the final solution of this reaction be acidic, basic, or neutral? So we go back here and we go, well, I've got a weak base acid with a strong base. And they're telling you that this salt will react. That's my conjugate base. Okay, that means I'm going to get a basic solution. Alright, I've asked you about hydrolysis. So what we have here is we have a weak acid with a strong base. So that's the first thing. So we know we'll get a basic salt. Okay, but the oxalic acid ion, the COO minus 2, will react with water. Okay, and it's going to form COOH2 again plus OH minus, and I need 2 of everything here. Okay, what does that mean for us? OH, so that's the hydrolysis of the anion of the sodium salt. So the OH minus ions, that concentration increases, therefore final solution is basic. We'll have a pH greater than 7. Okay? Then write a balanced equation to show the reaction between marble, CaCO3, and hydrochloric acid. Well, it's a carbonate plus an acid. That means you're going to get a salt, CaCl2, plus water, plus carbon dioxide. So we're going to need a 2 there, and that's my balanced equation. Okay? Straightforward. Let's just check. 2, yeah, balanced. Sometimes the stomach produces excess hydrochloric acid. When this happens, antacids are prescribed. Some antacids contain CaCO3, calcium carbonate. Explain using the equation from 4.3 why one takes an antacid. Well, the CaCO3 neutralizes the acid, producing carbon dioxide and water, which soothes the stomach. Okay, really is just about the neutralization of the acid. Okay, really not as bad as we think it is.